Once upon a time there was a digital repository in a big city, and all the teachers in the city could use lesson scripts that were kept in this shared library. Teacher could create their own scripts and could use and copy scripts from other teachers, and gradually, from one scenario to another, from those who create their own scripts and copy the script of other teacher, a community emerged. Some called it community practice, some called it invisible college. Science action of participants and on the digital object were recorded in the log file. We can trace the development of the community. Main point of my talk is that the community and special virtual learning community stories are not about user or digital objects, document photo programs. This story are about network structure, group teams, or other elements which emerge between user and object. And now we put this presentation, we go from this animated story to the presentation, and it will be continued. We go back. So, that is a story of Moscow Electronic School education community told by network analysis and engine-based modeling. A regular story about our community is about how many users, how many they create, and the way we look at the system and the way we talk about the system matter. Typically, community made viewed through the lens of time of existence, number of registered user, number of objects created by user, and messaging posted by them. Most of the time, it's a simple story available on community homepage or easily obtained upon a request. For example, we can type on the media wiki page, on any wiki page which use MediaWiki magic word, and you can immediately find how many registered users in the system and how many page they created. The same idea in many different community, maybe in Scratch as an example. So we have a community statistic, it's the same as a wiki page in Wikipedia, and we can see the dynamic of user registration and the creation of object and comments. However, this is about user, but not about the relationship. And what I try to do in the field of different education community is to find structure on the dynamic relation between users and social objects which they create and reuse it. So we try to use the same approach on a very different community where user can create and generate the content or collectively design the content. There are a huge variety of user-generated content community, and I have mentioned only my favorite maybe. It's Global Area Project, Scratch Community, of course, NetLogo Modeling, Common StarLogo, or StarLogo Nova, now Looking Glass, which use Alice language to create a digital stories. CloudWorks may be a very important community because they collaborate with teacher, and teacher create learning design, and there is an exchange of learning design and learning map. Of course, learning LetPC, our wiki project, and now we talk about Moscow Electronic School, because on the field of Moscow Electronic School we have the same principles. And that is an idea. On the first position stand Electronic Scientific Library, and that is the idea of invisible college as a network, which many participants are used in their work. It's not accidentally. I think that scientific library give us a theoretical framework and methods for studying different community as a branch of team science. Team science and network science are inside the science of science and team science. And there is two main points. Of course, the network is around us, and the ubiquity of networks are all aspects of our life: biological, physical, economical, and social. And there is an example of the network of football teams, which we can use these tools for our research, not only in science, as I think, physics or biology, but team science too. And other part of my presentation is democratization of network science, because now anybody can make a map using the data, using the tools that are accessible. And it is not easy to discover and map the social structure of community. That is why we need a special tool of social network analysis and agent-based modeling to augment our story, to make it much more clear. And the network science in school classroom is very special because, as Brent Robbins wrote, but postulating a friendship network in a school classroom of 25 students, we have taken a theoretical step that is not trivial. We have supposed that separate individuals are not an adequate representation. Moreover, than even separate yards are insufficient. Rather than there is a unity with the classroom that makes its proper talk a network, not a 25 or 30, 100 diets. The conceptualized the network in network term is an implicit claim that the contentness across individual elements is fundamental important, so that the classroom can be taught as one system. And after this preview of network science in school, in the school classroom, we go to the Moscow Electronic School, and we try to use the same approach to the library of Moscow Electronic School. It is a rather complicated system with multiple roles by user. So the actors of this repository can be teachers, students, parents, or publisher, anyone who performs the action on digital object. Now, I told a number. It's about 1 million script lessons inside of Moscow Electronic School library, and it's about 84,000 authors who participate in Moscow Electronic School. But we try to go from the number of how many users, we try to go to the network of this user, how they connect, how they interaction with each other. And we have a whole history of action by the participants, and the log is available for analysis. So we have an actor and agent of activity, the object of activity, it's a text scheme, presentation, lessons, or scenario of lesson. And we have a type of activity. It can be created, view, remixed, launch during a lesson, and add to favorite. So, and of course, and another is embedded in the network. So, on the basis of this action, we can make a relationship of teacher, and we can create a map not only for one teacher, but for all network of teacher in the Moscow Electronic School. So we go from teacher profile to action that the teacher made in Moscow Electronic School when he published, when he edited, or when he put it as a homework, or even when he copied the lessons from other teacher. And on the basis of this activity of teacher, we can make a map of reaction, of a relation of this teacher with other. So he used other teacher and scenario of other teacher in his work, and other teacher use his own scenario in their work. And so we can see the map of connection of using each other in the Moscow Electronic School. So what we try to do, and we try to show, to filter this mLearn function to the network structure that will be accurately reflect the community in which the participants are interconnected. So that is an example of our filtering procedure of network fraction. The first table is very huge. It's about 40 millions of action, and then on the second table we filtered the first, and we don't take action about, we don't know the affiliation of teacher or the affiliation of lesson script to academic subject, and we remove the action of user when they only view scenarios because we think that is not lead to the formation of connection between user. And the next table, and the third table, we filtered for the second table only action of the teacher who create and publish lesson script, because there is a lot of other activity of teacher who only use but they don't create their own scripts. And we go to the second part of our work when we are filtering network fraction inside the graphs. So we have first graph is bipartite because it's a user and learning script, and the second graph is a unipartite graph. It's only user, and the link between them have information about lesson script and the time when they have used the script. So we have use R language, and the action of filter action must be remixed, and age must be mutual. So the teacher Bob copied the script from teacher Anna, and sometime later the teacher Anna copied the script from the teacher Boris. This is the principle of reciprocal copying. And on the basis of this research we get the fraction of user reciprocally copied learning scenario. So when we look on it, it was very strange because we have a giant component contains mostly all nodes and links, and all other 145, 44 components have only 37 and 8 nodes, and that is practically nothing. So all components go to the giant component, and we try to understand how it can be done. It is a story what we, that we can talk with the R language and the package telegraph help us to store the teacher about teacher relationship. So we see on this graph the key player agent who stay and have a many connection with other players, and there is a bridge who make a connection between different groups, and we can use another filter, and we can use we can find only groups from with teacher from the same school, and we try that is many groups that is interconnected in the school, but they are not connected, they are not organized in very big huge groups and teams. And another approach of our research is using not only social network analysis but agent-based modeling, and is a generative science approach. So if you didn't grow the phenomenon, you didn't explain it. So you can explore how something emerges only if you grow it. So question of our research was, can we grow the artificial community of teacher in which 75% of users will be part of giant component? And we use media NetLogo language, and we choose it because the most of researchers in agent-based modeling speak it. And we choose NetLogo language because there is a several huge model repository when you can, which you can use in your research. It's a NetLogo model by itself. It's NetLogo modeling commons when everybody can put their own models, and it is a COMSIS and open ABM network where researchers publish their models. And we take a two model because they're very famous. One is flocking models, and we have an experience with it and use the variable vision. We have a lot of variables in this model, but we take only one, our vision, and we try to connect it with the velocity of flocking, how fast all birds or participants go to one direction. And we use behavior space tools inside of NetLogo, and the data of this experiment go to R language, and we see that after vision 4 there is no very big difference in our model, because all our birds or fish or participant of our activity fly in one direction. And the next model is the team assembly model, and this model use two variables: how many newcomer in model, a probability to work with newcomer, not incumbent. And another one is Q variable. It is about working with the same who worked previously. And we make an experiment of assembly experiment with this team, and we try to use variables of working with incumbent participant, and find that after 40 probability of choosing an incumbent, we can build the same situation as we have in Moscow Electronic School. So it is possible to grow the same structure in our model. After it, we go to simulation of reciprocal network formation in NetLogo media, and that is what we try to do and show in the special presentation. And the one thing I try to talk today, that we can a story of about every actor and links. We can put our mouse to each part of presentation of model, and we have additional information about each total or each agent. So that is our results. We think of Moscow Electronic School community as a community of scientists. That is the idea of invisible college. This allows us to use a theoretical framework and research methods developed for team science. And the result obtained from the analysis of digital trace of Moscow Electronic School are the results of scientific research, and it can be shared, and these results should be replicated by other researchers. Now we go again back to the animated story of Moscow Electronic School, and we shall see how it changed in time of our presentation. And I just make some remark about what we see on the screen, because that is the activity of our participant, and each time when we see the cursor on an object, it's the time when the link made, when somebody copied the project of other teacher. And that is a degree distribution, and we can see that mostly of them have only one or two link to other, but there is some key player who have much more links from himself. And that is a percent of agent in giant component. It's not big now, but we know that it will be mostly the 78% of participant in this giant component in the end. And that is a very interesting measure. The time from one teacher copied the project of other, and then the mutual copying back. So many, not now, but I know this information as a result of our experiment, that there is a big, huge community of authors who made the copying back just in the same day, maybe in the same hour. That was very strange. I think that is not so easy to explain why this immediate reward for copying the script. Okay, I think that is an active simulation that I show, and that is a way we can tell the story, not on the slide, not in a number, but in a simulation when all of our actors participate and we see a whole map of the activity. I will be glad to answer to your questions.